So, today, or this weekend, what we want to talk about are solving quadratic equations using the quadratic formula. Now, hopefully you remember this from Algebra 1, but just as a quick review, the quadratic formula is a formula that we can just plug in numbers and then it will tell us what x is equal to. It's a fantastic little thing, and I'm sure you may remember it. Some teachers use a song to help you remember. Opposite of b plus or minus the square root of b squared minus 4ac all over, whole thing over, 2a. And that is the quadratic formula. Now remember, we always have to get two solutions when we are solving a quadratic. That's why it has to have the plus or minus. Because we do the opposite of b plus this square root, and we do the opposite of b minus this square root, so we get two separate answers. We still have to get two solutions. Okay? Quadratics have two solutions. Couple of vocabulary words we want to cover real quick. This part of the formula underneath the radical, just the number underneath the radical, this is called the discriminant. The discriminant. And it is called the discriminant because it discriminates between what types of solutions we're getting. It tells us whether we're going to get two real answers, two imaginary answers, or that one repeated answer. And so, special property about that little number. Things to remember: if the discriminant is greater than 0, then we're going to get two real answers. Because when you take the square root of a positive number, you get a real number. So if it is a positive number, greater than 0, we're going to get two real solutions. If it happens to be equal to 0, that number is equal to 0, then we're going to get that one repeated solution. That means that the vertex is on the x-axis. And so that's why we use opposite of b over 2a to help us find the vertex, because the vertex occurs where the discriminant is equal to 0. Nifty little thing. Now the reason we get one repeated solution is the square root of 0 is just 0. Negative b plus 0 and negative b minus 0 is going to be the same thing. So we get the same answer twice. One repeated solution. Now, the other thing is if it's negative. If it is less than 0, well, the square root of a negative is imaginary. So that's when we end up with two imaginary solutions. Okay? So we have three options again for our two solutions. Two real, if the discriminant's positive. One repeated, if the discriminant's 0. And two imaginary, if the discriminant is negative. So this is our formula. Let's look at a couple of examples of how we use it. Let's say that we want to solve 3x squared minus 4x minus 2 equal to 0. First thing we want to remember is that it must equal 0. Just like all our other ones. If it doesn't equal 0, we can't solve it. So if it doesn't equal 0, we need to make it equal 0. But if it does equal 0, the second thing we need to do is find a, b, and c. Don't forget, a is the number in front of x squared, b is the number in front of x, and c is the constant. So in this particular problem, a is equal to 3, b is equal to negative 4, and c is equal to negative 2. Now, one thing I want to warn you against in using your quadratic formula is trying to plug it all into your calculator at once. There's two reasons to avoid that. One is it's got a square root in it. So if we just plug it into our calculator and we hit enter all at once, it's going to give us the decimal for that square root. And we know we have to get an exact answer. So there's not much point in me just typing it all in at once anyway, since I'm going to have to keep the square root in my answer. Two, most students don't use enough parentheses. There's too many things here. We have to keep all of this in the top, so we would have to put parentheses around all of this. Everything inside is going to have parentheses around it. Honestly, you should use parentheses for every variable. And so there's just too many parentheses. Somebody always forgets to close one of the parentheses, and then the calculator does the order of operations. Wrong for the formula, but right for what you plug into it. And so then it gives you a wrong answer too. So my suggestion when plugging it into your formula is to find the discriminant first. We want to know what is that number underneath that square root first. And that you can type into your calculator all at once. For this particular problem, I'm going to be doing b squared minus 4ac. So negative 4 squared. Notice I put the negative 4 in parentheses, the squared outside of the parentheses, minus 4 times a times c. Anytime I substitute anything in, I just use parentheses around it. So, negative 4 squared minus 4 times 3 times negative 2. And I hit enter. Okay, 40. So my discriminant was equal to 40. What that lets me do is it now lets me plug everything in a place where I can actually simplify it. So the opposite of b, the opposite of negative 4, would be positive 4. Plus or minus the square root of the discriminant, well, we just found out that was 40, all over 2 times 3 is 6. Now, a lot of times you get to this point and nothing can be simplified. And so that makes it great because then that's just our answer. But looking at this, I do see some things that can simplify. For starters, there's a perfect square that divides 40. 4. 4 times 10. So then I take my square roots. Remember, that's why we reviewed simplifying radicals before we started solving these things. And so this is going to actually turn out to be 2 on the square root of 10. Well, I've still got all that other stuff going on, plus or minus the 4 all over the 6. Now, notice I did not just jump right away and simplify this 4 and 6. And that is because you cannot reduce the fraction unless all 3 numbers that are outside the square root have a common factor. Like up here, the number that was outside the square root was 1. There's not a number other than 1 that will divide 4, 6, and 1. And so at that point, I couldn't actually reduce the fraction. But now that I brought that 2 out, 2 will divide 4, 2, and 6. So I can reduce this fraction. So 4 divided by 2 would be 2. Plus or minus 2 divided by 2 would be 1. And then 6 divided by 2 would be 3. So this would be my solution. It's the exact answer. Now, if you ever want to check, you can always type it into your calculator, get the decimal answer, see if that matches where you find the zeros. But, that does take a lot of time. But will it make sure you have the right answer? Absolutely.